Yes, yeah, both. When after everybody in the cohort has completed it. Yeah. I was marking it. I realized how difficult question 1 was unexpectedly. Okay. The Jixiao and Chinese New Year visiting question. I don't remember. Why is this blinking? Has it been blinking for very long time? Oh, okay, yeah. Oh, the hourglass is free. Oh, thank Why just on lunchtime you all don't go and eat, go and toilet, go and water? No, I'm not going to allow. You have lunchtime for a reason. You don't see that I have my peeing problems and I'm short of water during your lesson, right? How come? I can't get it connected. BTA2, alright, huh? Oh, okay. Alright. Okay, so last lesson, okay, we looked at median and quartiles already. Alright. I shall leave this practice now 3 as a question exercise for yourself to do at home. Okay, I want to continue. Okay, to look at continuous data today. So, as I mentioned previously, continuous data, okay, one of it is if, for example, okay, if I have the height of 30 girls in the class, okay, can take on very, very specific values, and we may not be able to actually keep track of every single value itself, so we want to have a continuous form, and that can be represented in a cumulative frequency curve. Right? So looking at example 7, it says that the heights of 200 secondary 3 students were actually being measured. The following cumulative frequency curve shows the measured heights. Okay, so we're going to learn how to make use of the cumulative frequency curve to estimate the median, interquartile range, and so on. Okay, to find out other data. Right? So earlier when we looked at cumulative frequency curve, we are only able to identify, let's say, the number of people, okay, that are of a certain height or lesser. So for instance, if we were to look at 150, okay, so there are 150 students that have a height lesser than or equals to 166 cm. Okay, so that is how we read a cumulative frequency curve. Now, we can only estimate because every point that we read from here is mostly estimated. We are unable to tell the exact data. So in part A, when we want to find out the median height, okay, when we recall about median, if we have, let's say, over here we have 24 students. The median, we will divide the 24 students, okay, into 2. So 12 and 12. In between, we will take, sum it up and divide by 2. That is if we have even data. But in the continuous curve, we have 200. I will look for the middle at 100. Okay, so I always look for the middle. And in this case, at 100 itself, the 100th person has a height of 159 cm. Okay, take note that we're looking for the median height. So median height equals to 159 cm. Okay, so this is where I read for the median. Okay. Part B, I want to find interquartile range. So just to recap what we range. Interquartile range is if I were to take the upper quartile, Q3, minus away Q1. Okay? So we first got to look for where is the upper quartile. When we recall how we do our upper quartile, we look at median first. Top half, we look at center again. Okay, that will be where the upper quartile is. Lower quartile will be bottom half, we look at the center. In this case, it is very nicely divided. So upper quartile, center is at 150. So from here, I will find the upper quartile. And that would be our 166. Okay, so Q3 equals to 166. Then for Q1, I look at the lower half, center, and that will be this point here, and we find that it is 154 cm. Then the interquartile range will be 166 minus 154, which is 12 cm. Okay. Right. Next, the range itself. Okay. Range, we will look at the span of the data. Okay. So from the smallest data to the largest data. Smallest data starts at 140 cm. Largest data, based on the curve, it ends at 190. So we focus on the start and the end of the curve, not about the axis itself, because it's not all the time that the curve fits so nicely into the axis. So in this case, we are looking at 190 minus 140. So we have a range of 50 cm. Okay. And in part D, I want to find out the percentile. Okay, so percentile is even more precise about quartiles. Okay, quartiles, we were dividing the data into 4 parts. Okay, whereas percentile, as the name suggests, we're looking at percentage. So we're dividing the data into 100 parts. So if you're looking for the 30th percentile, we want to find the 30th percent, the person that is at the 30th percent. So we do 30 over 100 times 200, and we find that the person that is at the 30th percent is the 60th person. Okay, this is not the answer because this is not a height, not a data. So we go on to the graph, look for 60, which is here. Use your ruler to guide yourself. Okay, and we find that the 30th percentile, which we usually denote it as a capital letter P, okay, with a 30 at a subscript, and answer is 155 cm. Okay, so this is space 60, P30. Understand about percentile, okay, is that, for example, in this example itself, when we see the 30th percentile, okay, which is P30 to be 155 cm, this means that 30% of the Sec 3 students have heights that are less than or equals to, okay, so depending on the question, okay, to correct myself, usually is less than or equals to, okay, 155 cm. Okay, so when we say that you are at the 75th percentile, okay, I'm sure you have seen the percentile word in your report books, right? Okay, So when you are, let's say, at the 75th percentile, okay, that means that at that mark, okay, there are people who actually are lower than you, alright, at whatever mark that you're getting, okay, because it's always less than or equals to, alright. So the median, okay, because we're talking about halfway, is also what we call the 50th percentile. We can also denote it as P50, okay. Then for the first quartile, right, 1/4 is 25%, so Q1 is equals to P25. And the third quartile, which is 75%, so therefore it's also the same as writing P75. Okay, so you need to be familiar with all these notations. Right. Moving on to question 8. Okay. Based on this curve, we have 500 students in total. Okay, so just do a check. The end of the curve should be meeting at 500. Okay, the last number of the axis itself may not always be the total number of students. Okay, so do I have an example? I don't have an example over here. Okay, but we just be careful in terms of reading for total number of students. Look at the end of the curve. Okay, I want you to spend about maybe 5 minutes, okay, to do A, B, and C. Right? Figure out the median mark, the interquartile range, and the 90th percentile. Okay? answer. Okay, as I walked around, I saw that some of you for median mark, you got 55. Okay, I just want us to be very careful. Okay, it's so misleading to think that middle means 300. Okay, because you take the number of points here and then you divide by 2. That's incorrect, yeah? Okay, because we are looking at the middle student out of the total population here. So total population is 500 because the end of the curve meets here. So 500 divided by 2 is actually 250. Okay, so 250 is here, and the answer that we should be getting is 51 for this median mark. Okay. Whereas for the interquartile range, okay, it may be difficult to actually eyeball it and then after that determine where is the quarter. So you may want to do some side calculation by taking 1 quarter times 500, okay, and that is equals to 125. So this is the position where the first quartile is going to be at. You go and look for 125. In this case, you have to read in between the boxes itself, and you will find that Q1 is equals to 40. I understand that my printing is not very well done, okay, for your worksheet, okay, so you may read it as 39 or 41, okay. Did anybody get numbers that are other than 40? No? Okay, so Q1 is equals to 40, yeah? Alright, so likewise, we do the same for the upper quartile. So 3 quarter times 500, that will give us 375. And Q3 will be equals to 62. Okay, so likewise go on to the graph, read for 375. Okay, and you will find that it is 62. Okay, so therefore interquartile range is equals to 62 minus 40, which is 22. Okay. Part C, 90th percentile. We look for the 90th percent out of 500 students. That is at 450. So at 450, which is here, you will read that P90 is equals to 73. Okay. Now for part D, okay, we want to estimate the passing mark if 70% of the students pass the test. How would you have solved this question? Dylan? Find 70%. So find the number of students. Okay, so the number of students that pass will be 70%, right? And that is 350. Then what next? So what is the passing mark? Find the number of students who didn't pass. Okay, so why do you want to find the number of students that didn't pass? Okay, so take note that when you calculate this 350, okay, you should not be reading it at 350. Because when you read it off at 350, right, okay, you're looking at the number of students that actually score less than or equals to that particular mark. Okay, because any data that you read from the curve is always less than or equals to that mark. Whereas in this case, because you're talking about passing will mean that you get more than a certain mark. So our 350 is being counted from behind, okay, 350 down. So that's why I need to find out 500 minus 350, okay, which is 150, which is the number of students that did not pass. Then we can determine from the graph that the passing mark is equals to 42. Okay? So you need to be very familiar with what is the context that you're given. Passing mark means getting more than the marks. Okay, we have that the cumulative frequency curves of two schools, okay, on the daily traveling expenses, okay, of 800 pupils in two primary schools. Alright, so each school actually has 800 students. We want to estimate the median for school A and school B, as well as interquartile range for school A and school B. I'll give you 5 minutes to do A and B, okay, figure out the median as well as IQR. take a look. What is A Quartiles answer? What's the median for school A? Bernice? 42 cents. Do we all agree? Okay. So median for school A is 42 cents. What about median for school B? 58 cents. Alright. Okay. Then what about the interquartile range for school A? Let me write it down. Interquartile range of school A, what would it be? Zhechen? Sorry? 26. Okay. So we get 26 because our upper quartile is 56, lower quartile is 30. So we get 26 cents. And then B part 2, our interquartile range, what would it be, Junyang? 25. Okay, how do you get 25? 72 minus 47 and 25 cents. Anybody else get something different? How about 24 cents? Okay, if your 24 cents is because 72 minus 48, that's also fine. Okay, I will accept that. Alright. Okay. Now my concern for this question will be for part C. Okay. Very commonly in this topic itself, okay, in your statistics, you will be asked to compare information, compare data. Okay. So in part C, we ask which school's pupils spend more on daily traveling expenses. Explain your answer. Okay. So we need to decide what is the data that we should refer to. Okay, and understand why is it that we actually use that data. So in this case, okay, understanding how interquartile range comes about. Interquartile range is only telling you how widespread, okay, how the spread is like for the middle 50% of the information, right? Whereas median itself is telling you that 50% of the people, okay, actually get lesser than or equals to 42 cents or 58 cents depending on what school, okay? So since the question is asking about spending more generally, we will rely on the median, okay, to actually do the comparison. Alright, so looking at the median itself, school A being 42 cents and school B being 58 cents, it will suggest that school B's traveling expenses is higher because 50% of the students spend at least 58 cents already. Whereas for school A, 50% of the students spend only 42 cents. So you can only imagine the remaining 50% actually in fact spend higher than this, or rather lower than this, okay? So depending on how you see it, okay? So in this case, to explain your answer, we say that school B, okay, rather pupils from school B, sorry, checking my grammar, more on daily traveling expenses. To explain, okay, we will say that it is because the median of school B is higher than that of school A. Okay. I want to emphasize that in doing comparison, okay, so this is a comparative, I don't know whether there's such an English word, okay. What do you learn in SS or history? It's compare and contrast. Comparative, there's such a word, right? Is there? Okay, so when you draw comparison, okay, you need to tell me what you are comparing to. Okay, so higher than that of school A. So you cannot just stop your sentence at because the median of school A is higher. You cannot just stop your sentence there. You need to tell me higher than what? Okay? So higher than that of school A. Right? So draw that comparison, be very clear in your statement. Okay, very often students tend to just stop it there. Okay, because we speak like that, okay, most of the time. But when we speak, there's a very informal way. Okay, so when we write, we need to write formally. So please draw that comparison. Okay. Now I want us to turn to our practice now 5. Okay, in your textbook, page 87. Okay, I will skip away with practice now 4 since you are highly capable of finding your IQR and your median already. Looking at page 87. Answers for A and B, okay, because my concern is about part C and part D. Alright, so in part A and B, we have already found the median and the interquartile range of the respective schools. In this question, we are looking at 300 students from each school who participated in an IQ quiz. Okay, maximum mark is 100. I just want to maybe just take this chance to let you know, okay, take note of the range itself. Okay, so for school B, the range starts at about 10, ending at about 96. Okay, so if you want to find the range of school B, it will be 96 minus away 10, whereas the range for school A is from 28 all the way till maybe about 86. Okay, so from the end of the graph. Okay, so pay careful attention if the question asks for range. Okay, so we look at the tips of the graph, okay, to know what is the range of the school itself. But that's beside the point. Okay, we're looking at comparing. Okay, state where with a reason. If school A or school B perform better overall, so what do you think? School A? How many of you will say school A did better overall? Who says school B do better overall? See, what do you think? If you draw a comparison to what we did in example 9, I already have the data over here. School A or school B do better overall? Sorry? B, right? Okay. So B is the one that did better overall because the median is higher. So to explain this question, or rather to answer the question, school B performed better overall since the median of school B is higher than that of school A. Okay? Right, so this answers the question whereby school B performed better overall, answers the idea of stating. And when you draw the comparison between the two schools, you're looking at the reason itself. Okay? Consistency. Okay, so to draw a difference between the two questions, yes, quickly go please. Okay, to draw a comparison between these two questions, okay, part C we're looking at overall, alright, the overall performance of the school, whereas in part D we're looking at consistency, okay, within the school itself, right? So in this case, we are looking at which school were the quiz marks more consistent. So if we have to compare, we need to look at the interquartile range. Because the interquartile range is talking about where we actually arrange all the students, okay, in ascending order. Then after that, we look at the middle 50%. Okay, so right at 50%, we see that in school A, it is having a 62 marks. Okay, so the middle 50% has a range of 18 marks, okay, within that 62 itself. Okay, so for example, this is all the data involved. Middle 50%. This is where the median is, which is 62. So this range itself is a range of 18 marks difference. So that's what we understand about interquartile range. Okay, so with an 18 marks difference versus for school B, it is a 23 marks difference, so a broader range. Okay, so with a broader range, it means that they are not very consistent. Okay, because if they are consistent, the range will be narrower, the spread will be narrower. You understand what I'm saying? Okay, so to answer this question, okay, when we want to look at a school that is more consistent, we want the one that is of a smaller number, okay, because they actually perform within a certain narrower range of marks. Alright, so yeah. Why can't we use the range? Okay, like I mentioned, the range itself, right, okay, is very easily affected by extreme values. Okay, so in this case, that's a very good question actually. Okay, when we have a cumulative frequency curve, we do not know the exact data of every single pupil. It's all based on an estimation only. In fact, I am just assuming that pupil number 10, okay, has this mark over here. Okay, but it actually may not be true because pupil number 10 may actually be getting a mark at 70, right? So therefore, okay, because of its influence by the range, by the extreme values itself, using range itself will not be an accurate, okay, justification to look at consistency. Okay, so therefore we look at the middle 50%, which is a narrower scope. We don't get influenced by extreme values that easily. Right? So school A was more consistent in its quiz marks because the interquartile range of school A is smaller than that of school B. Okay. looking at your schedule for next week, it seems very packed. Is it really one person have to go through all? Is there really one person in your class that has 5 WAs next week? Really? Who's that? Oh, so you take physics, you take A Maths, English, okay? Or geography, then pure and elect, and SS, wow. English haven't taken yet. Haven't taken. Not, so it was not done earlier. So Jared has to go through. Other than Jared, is there anyone else?
I got 6.
You got 6. Next week itself. Do you send this out to your form teachers? No what? By right, school policy is that, right? 1 week, each student maximum 4 tests.
Oh, legit. They remove SS.
Maybe you all never knew this. It was since you all set 1 what? School policy has always been that way. Confirm got say why you all never pay attention only.
You got 5 ah? I'm 6.
Have ah? Okay, let me go and ask. Okay, I'll go and check and ask about it. But of course, I cannot promise any changes for week 8 lah, because 2 last minute already. Okay, so let me go and ask about it so that it can benefit your juniors lah. I think you all don't have any more WAs, you see. Okay, anyway, so back to this. Homework deadline can be on end of the term. Then you have to matrices. Submit this week. Submit tomorrow. No, I want it to be together. I want it to be together. I don't like to collect these pieces. Then is it your problem or my problem?
It's your problem.
Yeah, it's your problem. I will not want it 2 weeks lah. Okay? Could I have it on week 8 Friday? So that you all can study, then Friday.
So physics going to study?
Week 8, right?
Physics going to
Yeah, no, week 9 you still have. You forever have exam. You're going to tell me O level. Okay, then you're going to tell me after O level that you want to submit. You can try. Okay? So, can I have it on Friday? Right? So, 26, yeah? 26, right? Because physics no need to study. Oh. Oh yeah, you all got practical exam. Practical don't need study one man. I thought need to plan experiment.
So 12 they don't study.
Okay. Okay, 10 minutes. Okay, let's just cover a bit of box and whisker plots. Okay, so a box and whisker plot is just another diagram that is a consolidated kind of diagram that focuses on 5 data. Okay, the maximum value, the minimum value, the median, the lower quartile, and upper quartile. Why is it called a box and whisker? It is because after you draw it, there will be a box and there are whiskers. That's why it's called a box and whisker plot. Okay? So how to actually go about drawing it? For instance, in this example, you are given the values already. We need to have a suitable scale. Usually, the scale is given to you. Axis is usually given to you. Okay? If it's not, just decide a suitable one such that it can contain the minimum value all the way to the maximum value. I'm sure you know how to draw your own scale already. Okay? Step 2, we indicate the position of all the 5 data. So this is the minimum value. Okay, maximum. Q1, Q2, and Q3. Okay? You need not actually label minimum, maximum, Q1, Q2, Q3, but you need to actually draw out those lines. Okay, you need to make a marking. Right? After you make the marking already, you complete it by drawing a box for Q1, Q2, Q3, and from the box itself, extend it out to the minimum, extend it out to the maximum. So that's all you have to do when it comes to a box and whisker plot. So from a box and whisker plot, it allows us to very easily tell what is the range, okay, maximum minus minimum, so that is 80 minus 10, so equals to 70. And it also allows us to see the interquartile range, which is 57 minus 42, that is 15. Okay? So a box and whisker plot, okay, is a way to summarize a set of data. It shows us, okay, in a visual sense how the spread is like. So if the box is very wide, okay, it's very long itself, it tells us that the interquartile range is very wide, okay. Whereas if the range is that the whisker ends up being very long, it tells us how much of a spread, okay, it is from the Q1 and Q3 or the overall data. Okay, so it allows us to draw comparison very easily. Alright? So we are only interested in 5 values that I mentioned. Box and whisker plot can also be drawn vertically, which I have an example in example 11. So it can be drawn vertically as well. Just like how number lines could also be drawn vertically. Okay? Let's just do a quick practice. Example 10. Okay, so draw a box and whisker plot for the given set of data. We cannot use unarranged data. We must always arrange the data in ascending order. So, doing a quick arrangement, even if the data is repeated, you got to write it down. A good habit is that when you arrange it, when you list it already, you just cancel so that you don't lose track. Or make sure you count. The number of data is the same. Okay? So what is the maximum value, Nicole? Maximum data is? Sorry, I can't hear you. 17, okay. And then the minimum data is equals to, Joshua? Minimum 3. Okay. Median, what would the median be? Shamin? 10.5. How do you get 10.5? 10 plus 11. So the reason is because in this case we got 3, 6, 9, 12 data. So our Q2 will be 6 and 6. Okay. So 10 plus 11 divided by 2. 10.5, and then Q1, what would Q1 be? Noi? Sorry? 4.5, so that is because we take this here to be Q1. So this set of data, center, 4 plus 5, divided by 2, 4.5. And then Q3, Li Hui, what is your answer? Upper quartile? 14. Okay, so looking at this set of data here, middle is here. So 14 plus 14 divided by 2 is 14. Okay, so we need to gather this data, then we can draw the box and whisker plot. In this case, the scale is not given, so we need to figure out our own scale. We need to encompass lowest 3 to 17. Usually we don't have odd numbers on the scale itself, so we start with even numbers. Okay, so let's say if this is 0, okay, 2, 4, 6, 8, 10, 12, 14, 16, 18. So I have enough, okay, boxes here to actually hold the numbers. So I will draw my number line. Oops. Okay. So 0, 2, 4, 6, oops, 8, 10, 12, 14, 16, 18. Okay, please avoid giving an odd scale, meaning to say 1, 3, 5, 7, 11. Okay, we usually avoid odd numbers for scales because difficult to read. Right? So we now indicate, mark out all these positions for the 5 values. Minimum is 3. So there's no need there's no fixed length that you need to have. Okay, but at least draw something big. Don't make a marking that is so small. So let's say 3 is found over here. Please don't draw a marking so small. Use the space. Okay, so no fixed size. Okay, but usually we draw within it, not the whole box, the whole grid itself. Okay, so minimum is at 3, maximum is at 17. Right? Median is at 10.5, so that means in between the square. Okay. Q1 is at 4.5. And Q3 is at 14. No need to be so OCD and then try to balance and make it artistic. You're not going to hang this up in the gallery. Okay, so then just connect the lines. The middle 3 will connect to form a box. While the ends will draw your whisker towards the box. Okay. Any questions? Okay, we'll end our lesson here today. Could someone do me a favor? Take a photo of this, WhatsApp it to me. Yeah, I'm serious. Yeah. Can you all take a photo? Carissa, do you have a phone with you? Help me take a photo, then WhatsApp me. Can? If nobody says anything, everybody is going to suffer.
Can I just send the web?
Send what?
The picture in the web.
Sure, go ahead.